Alright, let's continue with the introduction on deep learning, and let's go through some of the definitions and concepts and terminology. So here I have drawn a neural network with two layers. These layers we call dense layers. A layer is the building block of a neural network. Why do we call them dense layers? Well, because remember when we looked at the perceptron, we had these input units. So in this case you will have 512 of them. 512. So you have an input tensor, because TensorFlow Keras only understand blocks of numbers, so you need to transform whatever data you have into a tensor. You feed that to these 512 units, and out will come another tensor. That's why Google called its platform TensorFlow. Just tensors flowing through the network. The activation function we use for this dense layer, the first one is ReLU. You will be seeing ReLU a lot as the activation function for hidden layers. And then at the end, the second layer only has 10 units, and activation is softmax. So your second layer has 10 units, 2, 3, all the way down to 10. So this has 512 and this has 10. And the output is a probability distribution, because softmax is the activation. So the output is a probability distribution for y. And for example, if this is a neural network to recognize handwritten digits, these 10 units here is going to be your 10 digits. So this will be your 1, this will be your 2, this will be your 3, this will be 0 at the end. Now I should have started with 0, but basically it has 10 digits. And softmax will give you the probability distribution for these 10 digits. For example, the probability that it is a 1 is 0.1. Probability that is a 2 is 0.05. Probability that it is a 0 is 0.1. Probability that it is a 3 is 0.6. Right? So the sum of all these together, of course, should be 1. And in this case, you see the highest probability is for a 3. That means that the prediction will be that this digit is a 3. So that's how it works. So then you have your prediction 3, you compare it with the true y. This is supervised learning, so you have the labels. You know what the y's are in your training set. So you compare with the true y, and then you calculate an error, which is the difference between predicted and the true value. And that error sends a feedback loop back to the layer here, and this layer then will update its weights, the W and the B. So that's how it works. Now, the output of this first layer is ReLU of dot product of W and X plus B. It looks complicated, but it is not. Remember, we had a in the perceptron, we had that X0 W0 plus X1 W1 plus X2 W2. And was your output. Remember, we had 3 inputs, X0, X1, X2. And of course, this we can write in vector form, and this we've also seen. This is W transpose X and the dot product of that. So this is this piece, and you add B. Well, B we're going to try to integrate here because we don't like that B. So this X0 This x0 we will set to 1. Yeah. And of course the w0 will be our b. Right? So that's how we can actually integrate these into this dot product. Alright, so that's exactly what you see here, and of course you take the reloop of that function because it gives you other options. Yeah. So basically, what's a neural network? Well, it's a chain of differentiable tensor transformations. So basically, it's your tensor flowing through the network. Tensor in, tensor out. Differentiable, we need that because we'll be using gradient descent. Yeah? Another way of looking at it is if you would need to go from x to y predict in one step, you would need a very complex transformation. So the intuition is that with neural networks, we can break this very complex transformation down to a series of simpler transformations. Alright, so layer, we've defined it, it's a core building block of neural networks. It's basically a data filter. So it extracts valid information out of the data. Yeah? They call it representations, yeah? But basically that's what it does. Then we have a cost function. Yes, we will have a cost function and we will minimize the cost. Cost functions examples are binary cross entropy and categorical cross entropy. If you want to know more about these, I've explained it in detail in video 117. But basically, cross entropy is a measure to measure the similarity of two distributions. No? You compare the two distributions, how similar are they? In Keras, this will be called loss. Keras is the library that we will use, the deep learning library. And Keras is actually an API that lets you access TensorFlow. TensorFlow is Google's platform for deep learning. Yeah. Optimizer, well, we have RMS prop, Adam. We'll use both. RMS prop I explained in video 29, Adam I explained in video 30. Basically, Adam is a combination of RMS prop and momentum. Alright, so in Keras we will simply call this optimizer, so no issue here. And then we have performance KPI, the accuracy, for example. In Keras we will use the term metrics. Okay, model we've defined, this is your model, it's a network of layers. And then we still need to define epoch. What is an epoch? Well, an epoch is a complete run through the training data. Yeah? So it's one complete run, one complete iteration through the training data. We will need more than one epoch in order to converge to that minimum. Yeah? Alright, this should give us enough ammunition to start our first coding exercise. The first coding exercise will be on the Internet Movie Database, IMDb. And it's a data set that we looked at for naive Bayes, for example. So let's see how a dense neural network does on this IMDb data set.